So right now there are like millions of people scooping this white crystalline powder into their morning water.
Yeah, it's everywhere lately.
It really is. And I mean, it's not because they're prepping to go to the gym and deadlift a small car or anything like that.
Right. Definitely not doing it for the deadlifts.
Yeah, they're actually doing it because, well, they're terrified of forgetting where they left their keys, which is wild because creatine is basically the undisputed reigning champion of the hardcore bodybuilding world.
Oh, absolutely. It is the gold standard for athletes.
Exactly. But suddenly it's being heavily marketed to an aging population as this, like, cognitive shield.
It's a really profound shift in public perception. I mean, we're watching this compound migrate in real time from the sticky rubber mats of the weight room directly into the mainstream anti-aging wellness aisle.
It's quite a rebrand.
It is. And what's fascinating here is that the underlying molecule hasn't changed at all. It's the exact same stuff. What has changed is our collective anxiety about cognitive decline. That and the supplement industry's recognition of a massive, completely untapped demographic.
Which, makes this the perfect time to ask a question that is suddenly popping up everywhere. Should we all be taking creatine?
Right, the million-dollar question.
Literally. Like, should you, the person listening to this right now, be keeping a tub of this stuff right next to your coffee maker?
To figure that out, we really have to bypass those incredibly sophisticated marketing campaigns. We need to look at the actual physiological reality.
Yeah, we need to separate the undeniable biological mechanisms from all the theoretical hype.
Which is a vital distinction to make. Because the claims currently swirling around this compound, they range from highly validated scientific consensus to, well, absolute speculative fiction.
Right.
If we're going to determine if this is a universal biological necessity, we have to start at the cellular level.
Okay, let's unpack this, starting with what we actually know for sure. The hard science of muscle performance.
Let's do it.
We have sports nutritionists like Bethan Kraus from Lafboro University going on the record stating there is really substantial evidence for creatine's effectiveness.
That's a very heavy phrase in the research community.
Right. In the notoriously murky world of sports supplements, a prominent researcher claiming substantial evidence usually means the debate is essentially over.
And for physical short burst performance, the debate is indeed over. It is one of the most rigorously tested compounds in human history.
Oh, wow.
Yeah. But to understand why it's so effective, we have to look really closely at how your body manages its energy economy during severe acute stress.
Okay, so what happens when you demand an explosive movement? Like, say you're sprinting to catch a bus or lifting something really heavy.
Well, your muscles don't just burn fat or carbohydrates in that exact microsecond. That takes too long. They burn a molecule called ATP, or adenosine triphosphate.
The famous cellular energy currency. But how does that transaction actually work when you need power instantly?
Think of ATP as a coiled spring. It's got 3 phosphate groups attached to it. When your muscle needs to fire instantly, it just snaps off one of those phosphate groups.
Okay, making sense so far.
That chemical break releases a massive burst of energy, which fuels the muscle contraction. But now, your ATP is missing a piece. It becomes ADP adenosine diphosphate. It only has 2 phosphates left.
So it's essentially a spent, dead battery.
Precisely.
So if ATP is the battery and it dies almost immediately after snapping off that piece, is creatine basically the portable power bank plugged into the side, constantly recharging it?
It's close, but the reality is actually much more aggressive than that. I mean, a power bank takes time to trickle charge a dead battery, right?
Yeah, that's true.
Creatine acts more like hot swapping a fresh battery into the device the exact millisecond the old one dies. It's an instantaneous biological patch.
Wait, really? How does it do it that fast?
Through something called the phosphagen system. When you consume creatine, your body stores it in your muscles as phosphocreatine. Notice the phospho part there.
Right, so it's holding onto a spare phosphate group.
Exactly. The second your muscle fires, turning your ATP into a dead ADP molecule, that stored phosphocreatine rushes in. It acts as a molecular phosphate donor.
Oh, so it just spots the dead ADP and hands over the spare part.
Yep. It instantly turns it back into fully charged active ATP. You aren't waiting to metabolize food to make new energy. You are aggressively, instantly recycling the energy you just spent.
That paints a totally different picture. It's not just giving you more energy in a vague caffeine-like way. It is a highly specific recycling mechanism.
That's the perfect way to describe it.
And this local supply of ATP, like the amount you have before you need to recycle it, how long does that actually last in a high-intensity situation?
Literally seconds. If you are going at absolute maximum effort, Your local ATP stores are completely depleted in roughly 3 to 5 seconds.
3 to 5 seconds, that is nothing.
I know. And after that, your power output just drops off a cliff.
So for you listening, think about what that feels like. Say you're doing a set of heavy squats, or maybe you're on a stationary bike pushing a high-resistance interval.
We've all been there.
Right. Those first few seconds feel super powerful, but then almost suddenly the muscle feels like it hit a wall. It just stops responding with the same force.
Exactly. That is the exact moment your localized ATP is gone and your body is frantically trying to produce more.
So that's where the saturation of creatine comes in.
You got it. By keeping those muscle cells totally saturated with extra phosphocreatine, you delay that drop-off. Bethan Kraus highlights that this translates to measurable improvements in peak power.
That's huge for athletes.
It is. But more importantly, it improves the ability to sustain repeated high-intensity efforts.
Ah, okay. So it's the difference between doing one heavy sprint and just being totally exhausted versus doing a sprint, resting for a minute, and being able to hit that exact same peak speed a second or third time.
Precisely. You recover your explosive capacity much faster between bouts, which perfectly explains why strength athletes and sprinters have relied on this mechanism for decades.
Yeah, it's an exogenous way to manipulate a fundamental energy pathway. Makes total sense.
It really does.
So we've established that creatine is a rapid-fire energy recycler for high-intensity muscle contractions. The science there is rock solid.
Unquestionably.
But muscles aren't the only tissue in the human body that demand massive instant spikes of ATP, are they? Which, I guess, brings us to the real reason this compound is suddenly everywhere, the brain.
The transition from physical output to cognitive longevity, which is the logical next step for researchers. I mean, the human brain is an absolute metabolic furnace.
It's an incredible energy hog.
Oh, massively. It only accounts for about 2% of your total body mass, yet it consumes roughly 20% of your body's energy.
And if creatine acts as this universal hot swap battery for cellular energy, it makes sense that biologists start asking, well, what happens if we flood the brain with it?
Exactly. Especially in an era where we have a rapidly aging society, and the fear of neurodegeneration is just profound.
Yeah, that fear is a powerful motivator.
It is. And if we connect this to the bigger picture, the societal context is crucial here. We are witnessing an explosion of age-related cognitive diseases, and we genuinely lack highly effective pharmaceutical interventions.
So people are desperate for a solution.
Right. So when researchers suggest that a cheap, widely available sports supplement might offer neuroprotection, the public reaction is intense. Kraus notes that larger studies have recently brought this cognitive angle into focus.
Trying to see if this energy recycling mechanism can protect neurons from the metabolic stress that leads to decline.
Exactly.
Okay, let's unpack this cognitive angle, because this is where I think we really need to put our skeptical hats on for the listener.
We definitely do.
We see these phrases like developing research or early signs getting thrown around on social media, and they're presented as if they are absolute, undeniable proof that creatine is a miracle smart drug.
It's so common on those platforms.
If the research is still developing, are we totally jumping the gun by treating this like a proven brain booster?
We are absolutely jumping the gun. Treating the cognitive claims with the same level of certainty as the physical claims is, frankly, scientifically irresponsible.
Wow, okay. Strong words.
Well, it's true. We are taking the substantial evidence from the muscle side of the equation and just blindly pasting it onto the brain side, assuming the biology transfers perfectly. But it doesn't.
Wait, why doesn't it? I mean, if the brain uses ATP and creatine recycles ATP, shouldn't the math be exactly the same?
You would think so, but it comes down to the blood-brain barrier. Your muscles are relatively easy to access. They have specific transporters that aggressively pull creatine from your bloodstream right into the muscle tissue.
Okay. And the brain?
The brain operates under entirely different security protocols. The blood-brain barrier is a highly selective, semi-permeable border. It protects your brain from circulating pathogens or chemical fluctuations.
Right, it's like a VIP bouncer.
Exactly. It does not readily allow large amounts of systemic creatine to just waltz in.
So even if you are swallowing large doses of this powder, it's hitting a physiological brick wall before it can reach the neurons.
It hits a very, very stubborn filter. In fact, the brain mostly synthesizes its own creatine locally. It doesn't rely heavily on the supply circulating in your blood.
Oh, I had no idea.
Yeah. Studies have shown that while you can increase brain creatine levels through oral supplementation, it takes significantly higher doses and a much longer period of time compared to saturating muscle tissue.
And even then, is the increase significant?
Even then, the increase is modest at best.
So the supplement companies are executing a brilliant marketing sleight of hand here.
That's one way to look at it.
I mean, the underlying logic sounds completely bulletproof, right? Your brain needs energy, creatine gives energy, therefore buy our product for your brain. But they are conveniently ignoring the massive biological roadblock sitting right inside your skull.
The logic is sound in theory, but it's incredibly complex in practice. And this is why researchers like Kraus are so careful with their wording.
Right, they aren't making these grand promises.
No. I mean, yes, there are interesting studies showing that under extreme metabolic stress like severe sleep deprivation or traumatic brain injury, extra creatine might offer some cognitive buffering.
But a buffer against extreme stress is very different from an everyday brain booster that, makes you smarter or immune to aging.
Exactly. It's a completely different context.
So we have a compound that is definitively proven to enhance short-burst physical performance by recycling ATP in the muscles.
Yes.
And we have a compound that has a tantalizing but ultimately unproven and heavily obstructed pathway to potentially supporting brain health under stress.
That is the perfect summary.
Which brings us to the ultimate question for the person listening to this right now. Should you be taking it?
If we look closely at the expert consensus, the answer is surprisingly conservative. Kraus states unequivocally that claiming everybody should take creatine is simply a jump too far at this stage in the science.
A jump too far. That is such a refreshing dose of reality in an industry that relies entirely on convincing you that you are deficient in whatever they are selling.
It really is the difference between biological optimization and biological necessity. The consensus provides a very specific set of criteria for who actually warrants this supplementation.
Okay, let's hear the criteria.
First, are you engaged in serious physical training? Are you actively looking to improve peak power output in high-intensity, short-duration efforts?
And let's be honest about what that means. We aren't talking about going for a light 30-minute jog or doing a restorative yoga class.
No, not at all.
We are talking about pushing your physiological limits in a way that aggressively drains that localized ATP.
Exactly. If your workouts do not fundamentally challenge that phosphagen system, the exogenous creatine is largely redundant.
Makes sense. What's the next criterion?
There is a second, even more critical prerequisite. Have you already optimized your foundational nutrition?
This is where things always seem to come back to reality. It's the idea of earning the right to use the supplement.
It is the hierarchy of biological needs. If you meet those criteria, you are a high-level athlete, consistently draining ATP, and your dietary foundation is flawless, then yes, supplementation is highly validated.
But for the vast majority of the general population,
It remains an optional luxury. It's not a fundamental requirement.
and what fascinates me is the alternative to that tub of white powder. When we start looking for ways to actually support physical and cognitive health long-term, the most effective answers aren't synthesized in a lab.
No, they're not. They're sitting right there in the grocery store.
We keep chasing these isolated compounds, but researchers consistently point us back toward whole food sources, particularly for brain health.
Because whole foods do not operate as isolated chemical patches. They operate as complex synergistic matrices.
Which our bodies actually know how to process.
Exactly. When researchers emphasize the importance of dietary sources for cognitive preservation, they consistently highlight oily fish things like salmon, mackerel, sardines.
And unlike the highly debated, heavily filtered pathway of creatine to the brain, the relationship between oily fish and cognitive health is deeply established, isn't it?
Consistently established. And the mechanism is entirely different. Oily fish are rich in GHA and EPA omega-3 fatty acids.
Right, the omegas.
These do not act as hot swap batteries for instant energy. They act as actual structural building blocks for the brain.
Oh, that's a big distinction.
It's massive. They are integrated directly into the lipid bilayer of your neuronal cell membranes. They improve the fluidity of the cells, allowing for better neurotransmitter signaling, and they aggressively reduce chronic neuroinflammation.
So if creatine is theoretically trying to hand a spare battery to a neuron, omega-3 fatty acids are fundamentally upgrading the structural integrity of the neuron itself. One is fuel, the other is architecture.
Exactly. And the same applies to the plant-based alternatives frequently highlighted by nutritionists.
Yeah.
Flaxseed, chia seeds, walnut.
It's staples of a good diet.
Right. These provide alpha-linolenic acid, which is another crucial fatty acid, alongside a massive influx of polyphenols and antioxidants that protect those cellular structures from oxidative damage.
It's just wild to me. We look at a piece of salmon, or a handful of chia seeds, almost like a chore, right? Like a boring dietary obligation.
Yeah, people really do.
But we look at a tub of synthetic powder with neon lettering as this high-tech biohack. The psychology of this is just fascinating. The shortcut culture has us completely backwards.
It is the allure of precision. A white powder feels clinical. It feels like a targeted intervention. You take 5 grams and you imagine an immediate surge of ATP.
It feels like you're hacking the system.
Exactly. Eating a salmon fillet lacks that modern pharmacological romance. But human biology did not evolve to thrive on isolated synthetic compounds. It evolved to extract complex interwoven nutrients from whole foods. When you consume the fish or the seeds, you aren't just getting one pathway activated. You are initiating thousands of concurrent beneficial reactions that science is still struggling to fully map out.
So, synthesizing everything we've explored today, where does this leave you, the listener?
Well, it depends on your goals.
Right. If you are a competitive powerlifter, a sprinter, or someone whose entire training philosophy revolves around repeatedly hitting a wall of muscular exhaustion, creatine is a phenomenally effective, scientifically validated tool. The ATP recycling mechanism is real, and it works.
It absolutely does. But if your primary concern is long-term cognitive health, avoiding neurodegeneration, or simply feeling mentally sharp as you age, do not let the marketing hype dictate your strategy.
Yeah, that's crucial.
The neuroprotective research surrounding creatine is fascinating, but it is currently obstructed by biological realities like the blood-brain barrier. It is a promising frontier, but it is far from a settled solution.
Nail the basics before you buy the extras. I think that is the ultimate takeaway here.
I could agree more.
It is so incredibly tempting to try and out-hack our biology, to think we can just skip the foundational requirements of high-quality whole foods and patch our metabolic pathways with a scoop of powder. But your brain and your body are far too complex for a single chemical shortcut.
Which brings us to a really unavoidable evolutionary paradox.
Oh, what's that?
We are a species actively seeking out synthetic energy supplements because we feel chronically fatigued, both physically and mentally.
Very true.
Yet simultaneously, we are chronically underfueling ourselves with the actual natural building blocks our bodies require to function optimally. We are trying to tune the engine of a high-performance sports car while refusing to put the correct oil in it.
It raises such an important question for you to mull over. If ATP is our body's ultimate energy currency, and we're constantly looking to buy more energy through synthetic supplements like creatine, are we trying to out-hack our own biology before we've even given our bodies the basic natural foods they evolved to run on?
It's a sobering thought.
It really is. And it leaves you wondering about the future trajectory of all this, because if we eventually do crack the code, if, like a decade from now, deep long-term studies definitively prove that compounds like creatine absolutely prevent cognitive decline, will our perspective shift entirely?
That's a fascinating hypothetical. Will they stop being seen as optional fitness luxuries?
Exactly. Will they start being treated as fundamental public health requirements? I mean, think about it. We already fortify our public drinking water with fluoride to protect our teeth from decay.
Right, that's just a standard practice now.
So if the data becomes undeniable, could we see a future where cognitive supplements are fortified right into our municipal water supply, treating the aging brain with the same aggressive public health strategy as a cavity?
Wow. It's a wild thought, but given the trajectory of this research, it's not entirely impossible.
Not at all. Well, thank you for joining us on this deep dive.
It was a pleasure.
To everyone listening, stay curious, keep questioning the marketing hype, and remember that sometimes the most advanced biological hack you can perform is simply making yourself a great piece of salmon for dinner.